Hello everybody and welcome back, and in this tutorial we are going to look at a library in Python which is called Scapy. Now what Scapy allows us to do is actually configure our own packets and send them by our own needs. So we can send the packets, wait for a response back, we can print the response, we can do a bunch of other things, so we can basically manipulate with the packets that we actually send to the target. Now this helps us to understand better our ARP spoofer that we are going to code. So first of all, what we want to do is actually just check how the ARP packet is constructed to see its available fields and to actually change some of the fields and see what we can do with the ARP packet. But before we do any of that, I just want to introduce you to a certain command that you can run in both command prompt on Windows and in terminal in Linux. If you just type ARP -a, you get the ARP tables of this certain machine. As we can see, the ARP table is basically a table consisted of the IP addresses and the MAC addresses. Now what this allows our machines to do is to actually communicate with one another, since now my machine knows that the IP address of 192.168.1.1 is affiliated with this MAC address right here. So once it wants to communicate with the 192.168.1.1, it basically communicates with this MAC address. What ARP request allows us to do, which we will code just in a second, is it allows us to get the MAC address of a certain IP just by sending the ARP request. Then someone sends the ARP reply back and we get the MAC address of our target. So let's see how we can do that. Scapy, as I said, is a library by itself. We can just run Scapy instead of Python, and in order to do that you just type Scapy, and this should open the Scapy interpreter, which allows us to construct our own packets. So we can see it has opened. It looks similar to the actual Python interpreter, and here syntax is a little bit different. You can do a bunch of other stuff you can do in Python, but most of the stuff you can actually do. So first thing we want to do is see what actual fields does the ARP request have, or basically ARP packet. It doesn't have to be request, it can be reply also. And in order for us to actually do that, we need to type just ls, and in the brackets ARP, type ARP, close the brackets, and it will print out the available fields that the ARP packet has. As we can see, the P destination is the IP field of a target we want to actually get the MAC address from. The hardware destination is the MAC field of the target, which the hardware address or MAC address we want to get. The P source and hardware source is basically our IP field and MAC field. The OP is basically the type of packet we want to send. The 1 stands for the request and the 2 stands for the reply. So you can send this OP value to be either 1 if you want to send an ARP request, or 2 if you wanted to send the ARP reply. So let's see how we can actually construct a packet in order to get the same MAC address from this command from our router. So the IP address of router is 192.168.1.1, and we want to get the IP address or the MAC address of that router. Let's pretend we do not know it. So in order to do that, what we can do is first of all create a broadcast packet. So in order to do that, you just need to press equal ether, and in that broadcast packet, since we will concat it to the ARP packet, we want to select that we are actually sending this packet to the broadcast MAC address. Now what the broadcast MAC address is the MAC address where actually every machine on our local area network will receive this packet, and if some machine knows the answer to our question, it will respond back. In order to select to a broadcast MAC address, we need to select the DST field right here to be equal to this MAC address. So just select it like this, equals to FF, and once again FF. This is the MAC address of the broadcast, this is the broadcast MAC address which we are going to send the packet to. So just click enter right here. And since we created the broadcast packet, all we want to do right now is also create the ARP packet. So in order to do that, you just make ARP packet, for example. Let's call the packet like that. We set it to be equal to the ARP. So just type capital ARP, open and close the brackets. And let's say we want to actually set the, let's actually see what we want to set in this ARP packet. So we want to set the P destination field to be the IP address of our router, since it's the router's MAC address we are looking for. So in order to do that, you just need to select this field right here, copy the name of it, paste it right here, and type equals, and there you can actually set it to be the 192.168.1.1, which is the IP address of our router. Press here enter, and you successfully constructed the ARP packet, which has this value under the field of P destination. In order to check it, you can just type ARP packet.show with open and close brackets, and there you will have all the things that this ARP packet has specified. Now, as you can see, some of these things are specified by default, such as the HW source and the P source, which is our MAC and IP address, which basically is set by default since the escapee can recognize what our IP address is and can see what our MAC address is. Now, if this for some reason doesn't specify for itself, you can check both of your MAC and IP address by just typing ifconfig in your terminal. As we can see, my IP address is 192.168.1.7, which is selected under the P source field. My MAC address is this MAC address, which is selected under the hardware source field. So let me just, in case you are not seeing this very well, let me just zoom it like this. Then I will move this a little bit to the side, just like this. Move this all the way down. Just make it a little bit prettier. Okay, so it's good right now. And we can see that all we actually have to do right now is concat these two packets. Since we are looking for the actual MAC address of the router, we want to send our request to the broadcast MAC address so all PCs or all machines on the network can receive it. In order to make these two packets into one packet, we can just do the final packet, so let's call it final packet, equals, and all we have to do is just make a simple statement that looks like a division in Python, so broadcast, and then the /ARP packet. So we created our final packet, which we are going to send right now. So in order to check the fields of your final packet, you can just type final packet.show, same as the ARP packet, and you can see that our final packet has the Ethernet field, and under the Ethernet field it has the ARP field right here. This source is our MAC address, this destination is the MAC address of the actual broadcast, and this right here, the type, is the type of packet that we have under our final packet, which is the ARP packet. So 0x86 basically, or pardon me, 806 stands for the ARP packet. So all we have to do right now is send this packet to the target, or basically to the broadcast MAC address, and wait for a reply back, which then we will store in a certain variable which we can print afterwards. So let us call that variable answer, since the answer is what we are looking for after sending this packet. And in order to send it, we can just type srp, and in the brackets, we need to specify which packet are we going to send. So we are sending, of course, the final packet, since that is the packet that actually consists of both the Ethernet and ARP field. We can set the timeout to be equal to 2 seconds. And we can set the verbose to be equal to true, so we can see what actual oops, let me just check this out. What actual things is this performing? Since this answer will actually return a list, and the list consists of the answered and unanswered basically responses, we want to select only answered, so we will select the first list, which will be under the value 0. So click here enter. As we can see, finished sending 1 packet, received 1 packet, got 1 answers, remaining 0 packets. So someone sent our answer back. In order to print that answer, we can just use the actual, let me just show you, we can store it in the variable, which we can call MAC address, which will be the MAC address of our target, which we want to get under this field, which is the hardware destination. And all we want to do is select the answer. Or let me, before I do that, just show you, if I just type here answer, you can see that the results is under the other. So what we want to do is select a certain, let me just show you, if you just type MAC address equals and then answer, we take the first argument and the second argument of that list, And what the field that we want to actually get is the HWDSD, which is the hardware destination. So all we have to do is press dot afterwards and type HWDSD. So just press here enter, and now our MAC address is stored in the MAC address variable. So we can just print MAC_address, and you can see that right now we got the MAC address of, let me just check this out. Why did we get our own MAC address? That is a really good question. Well, for some reason, maybe I selected something wrong, but for some reason, oh, pardon me, we are not looking for the actual, or we are actually looking for the hardware destination. And what did I actually select right here? Let me just double check everything in order to see if I selected it correctly. Let's print the MAC address. Okay, so hardware source. Of course, I was confused a little bit because I selected right here the hardware destination as to the actual field where the router's MAC address will be, but the hardware destination is actually our own MAC address. And now you might be asking, why is that, since here it is the hardware source, which is our own MAC address. Well, this that we sent is a request, and the value that we are printing is the value from the response which was sent from the router. So basically, the router's packet is having these two fields flipped as to us, so the hardware destination will be our MAC address and the hardware source will be the router's MAC address, since the router is the one that is sending this packet back. And we can see that the router's actual MAC address is this one. So that would be basically it on how to actually get the MAC address from a target. Now, in order to actually create a malformed packet, what we can do is actually craft a packet which will specify wrong thing. Now, by wrong thing, I mean that we can actually fool our Windows 10 PC into thinking that the MAC address of the router is our MAC address. Then what our Windows 10 PC will do is it will send all the packets back to us. And since we haven't anything else specified, the actual Windows 10 PC will lose its connection to the internet. So let us see how we can create a malformed packet. So let me just see if I can, what we can do is actually make a variable called packet. And this variable packet will be an ARP packet, which we will then send. And what we want to do is, since the first packet we actually sent was a request packet, which was under the OP and equal 1, what we want to do is make OP equal 2, since right now what we are sending is the actual response. We want to send the response to the Windows 10, even though they never sent us our request. We want to send them a response saying that we are the router. So we can do that with OP equals 2, which is the actual response. The hardware destination is equal to the actual MAC address of our Windows 10 PC, which we can actually get since we don't actually have. So let us see how we can get it. We can make our final packet .show. We can just change a little bit of code in our final packet. So in order to do that, we need to change the final packet dot, let me just check it right here. I believe it is the the P destination has to be equal to the IP address of my actual Windows 10 PC. So let me just check it out. It is 192.168.1.5. So we select 192.168.1.5. Whoops, not 6, 5, instead of the router's IP address. And all we have to do is actually just use the same command from before. Final packet, timeout. We want to send the, oops. Wait, let me just check this. Don't actually execute these two commands. My keyboard actually, not really sure why it did it, but we can just ignore these two commands, and we want to send this final packet once again. So in order to send it, we use the same thing as before. So we will use a variable answer again, And that answer, we will send the packet, so we can use the final packet to send it. Timeout will be equal once again 2 seconds, just in case. We can use the verbose to be false right now, it doesn't really have to be true. And we use the first list answer right now, so we see if it got answer. It got answer under the section other, and all we want to do is actually set the MAC to be equal to the answer. We select the first value, open square brackets 1, and we want the hardware source. And we want to actually print MAC right now. So this is the MAC address of my Windows 10 PC. And right now we can actually send the malware packet to my Windows 10 PC. So let me just run ARP-8 in my Windows 10 just to see once again what the actual MAC address of the router is. So the MAC address of the router is this, and now we will change it to be this, since this is the MAC address of my Kali Linux machine. So let us see how we can do that. We will select a packet variable to be equal to ARP packet OP2 once again, since we are sending the response. The hardware destination, so hardware destination will be equal to the MAC address of our Windows 10 PC. So let's copy it, select it under the double quotes, paste it right here, and then all we have to specify again is the actual P destination, so the IP address of our Windows 10 PC, which will be the 192.168.1.5. And here, what we want to select is the P source. So P source, not really sure. Let me just move this to the side so you can see it a little bit better. So P source equals the IP address of the router actually. So what we want to select is that our source IP address is actually 192.168.1.1, which will then trigger the actual, where is my actual packet going? Okay, so here it is, which then will actually trick the router into thinking, I'm not really sure what is happening with my actual terminal, but it doesn't really matter. What I just added at the end of this command is the actual bracket, which for some reason added up right here, but it doesn't even matter. Right now we need to send this packet in order to trick our Windows 10 PC into thinking we are the router. So how we can send? We can just use send and then packet, since that is the name of our packet. We can send the verbose to be false since we don't need it. And we just send the packet. And right now, if I just type ARP-A once again, you can see that right now the MAC address of the router has changed. So we successfully changed the ARP table in our Windows 10 PC into thinking that we are the router. As you can see, the IP address of my Kali Linux machine and the IP address of the router both have the same MAC addresses, which shouldn't be like that. So we successfully ARP spoofed our Windows 10 machine with one packet. We crafted the packet and then we sent it to the target. What we will do in the next video is we will actually make a program that will do this in a while loop, so we can actually spoof the Windows 10 PC as much as we want, and also we need to spoof the router as well. So we need to spoof two targets in order to make this actually work, since only spoofing the Windows 10 machine will not do us any good, since the router still knows that the MAC address of the Windows 10 PC is its true MAC address, and we want to spoof the router as well, so the router sends packets back to us. So we will see how we can do that in the next video. Hope you enjoyed this little demonstration. Not really sure what happened with my terminal right here, but everything finished well. Hope you enjoyed it, and I hope I see you in the next video. Bye!